Hello, everyone. This is Brad Hallwagon, the Vice President of National Hydrologic Warning Council. Welcome to our June webinar. We have a great speaker today, Mr. Michael Jablonski, the Chairman of the SDI-12 support group. We've kind of been working our way down through the hydrologic warning processes. We started with planning and modeling and hydrology, and got into data collection, and now we're getting into telemetry. So I'm pretty excited because this is a field that I'm not that well versed in myself. So just a reminder, we are recording this webinar and we will post it to the YouTube channel afterwards. For those of you who are in attendance, you will get 1 hour of credit towards your Certified Floodplain Manager certification with ASFPM. So I'll send out the link and the certificate hopefully promptly after the meeting. It depends on when I can get the certificate from my designer. If you do have questions that come up during the webinar, whether they're related to the presentation or connectivity or anything, there's a chat box that you're able to type into. I will not be unmuting everyone just for the, I guess, the general safety of the presentation to make sure that Michael gets his time. Before he begins, though, I do have a few announcements that I want to run through. The first one is that we are currently in our open nomination period for our NHWC 2021 to 2023 Board of Directors. So every 2 years we elect what could possibly be a completely new Board of Directors. It's a 9-member board. I put the link up there for the nomination form. It's a Google form, so unfortunately that's about as short as I could get the link. If you didn't get that email from us, then you can go ahead and, if you want to, just email me directly. I can be reached at vicepresident@hydrologicwarning.org, and I can make sure that you get that link and that you can also make sure that you're on our mailing list. So the deadline for nominations is July the 8th, and then once nominations are over, we will hold elections July the 12th through the 23rd. Also want to remind y'all that we are having a Texas workshop in person this year. It's going to be held October 13th and 14th, 2021 at the Embassy Suites in San Marcos, Texas. Looks like a really, really nice hotel. I'm excited about being there. The Texas workshop is typically like a mini conference, and so it runs the gamut of all the flood warning system topics, maintenance, field maintenance, lessons learned, alert 2, hydrologic technology, data collection, modeling, forecasting, mapping, and even dam safety. We know there's a lot of that going on, especially in the state of Texas. So we hope that y'all can attend, and I'm looking forward to seeing a lot of y'all in person for the first time in quite a while. And then the last reminder I have, if you're not on our mailing list and aren't getting our emails, it's very possible that your emails are either out of date or they're somehow being blocked by the system. So if you find yourself not getting emails from the NHWC, again, you can just reach out to me at vicepresident@hydrologicwarning.org, and I can make sure that your contact info is up to date. So at this point, I'm going to change the presenter over to Michael, and I'll let him introduce himself and talk about the ins and outs of SDI-12.
Thank you.
All right.
Okay, my name is Michael Jablonski, and I am the chairman of the SDI-12 support group. And the SDI-12 is a communication standard between microprocessor-based sensors, typically water quality sensors or stream stage sensors, water flow sensors. And I have been working with SDI-12 quite intensely since it first came out. It came out in 1988, and I've been working with it for many, many years, ever since 1994 about. And I've been the chairman of the SDI-12 support group for a very long time. The SDI-12 and has a written standard. It is kept updated and maintained by the SDI-12 support group. I am actually the primary author of the SDI-12 specification. It's quite long, it's 60 pages. We're not going to get into all of the details by any means, but I've had an enormous amount of help over the years, including a significant amount of help from the U.S. Geologic Survey, the Hydrologic Instrumentation Facility in Mississippi, okay? The SDI-12 support group, I'm going to try to move some things out of the way here. The SDI-12 support group has two purposes. It's a nonprofit corporation. The first is educational. We publish the SDI-12 specification and help people understand SDI-12. The current version of SDI-12 is at version 1.4. The second is scientific. We upgrade the specification as needed to facilitate the collection of environmental data using the SDI-12 standard. The support group is a nonprofit corporation, and anyone or any agency, any company is welcome to be a member of it. Membership dues are $300 a year, and that we're a very low budget operation. By the way, there are no employees of the SDI-12 support group. Okay. I've got a technical glitch here where it's not changing slides. I cannot explain that. Yikes. There we go. Okay, the history of SDI-12. SDI-12 was created in 1988 by a group of private firms in the U.S. Geological Survey's Hydrologic Instrumentation Facility. HIF came up with a requirement. The key requirement was low power standard interface between the data recorder and intelligent microprocessor-based sensors at remote sites. It was to be a very simple interface with working in small processors, and the goal was for all sensors using the SDI-12 standard will work with all data recorders using the SDI-12 standard, and that goal has actually been reached. In 1991, because of many questions about SDI-12 as it was getting more and more use, the SDI-12 support group was formed, okay? The advantage of SDI-12, again, SDI-12 stands for Serial Digital Interface at 1200 baud. It's a rather slow communications protocol, but it's fast enough for environmental data. And all properly designed SDI-12 sensors will work with all properly designed SDI-12 data recorders. You can move sensors in and out of a programming network with ease. It's very, very low power consumption, and power is supplied to the sensors through the interface, and it's backward compatible. A sensor that was made, say, in 1988, literally would work with a data recorder that was made in 2021 by design. SDI-12 is used worldwide. This is a list of companies that are known to have SDI-12 product suppliers and users. Canada has used it. It's used in stream gauging stations all across the United States. I think there's somewhere in the neighborhood of 20,000 USGS gauging stations in the United States, and SDI-12 is used at probably 90% of them, and the USGS requires SDI-12 in the instrumentation as one option that they place in these stream gauging stations. SDI-12 is what's called multi-drop and multi-parameter. Multi-drop means that more than one sensor can be connected to a data recorder. Multi-parameter means a sensor may take more than one measurement. For example, some water quality sensors using SDI-12 measure temperature, conductivity, depth, pH, dissolved oxygen, turbidity, and oxidation reduction potential. So it's a very powerful interface. Here's how it looks when you're connecting sensors in a little block diagram. It's a very, very simple connectivity. You have 3 wires, and that wire is shared across the sensors. That's called the SDI-12 bus. This example shows 2 sensors connected to one data recorder. There's a serial data line that is a bidirectional line, which the data transfers one direction at a time, commands going to an SDI-12 sensor, and responses from the SDI-12 sensor being returned to the SDI-12 data recorder. Every sensor has a unique address, which is a single character. It's a number or a letter. Typically they start with address 0, which is the character 0, not the number 0, but just think of it as a 0 for simplicity. And you can add on more and more sensors as needed. You can go up to 10 sensors pretty easily. And the wiring and connection of additional sensors is very simple, okay? There's a communications protocol, and SDI-12 is a protocol between the data recorder and the sensor, and the data recorder sends a command to a sensor at its unique address telling it to do something. The sensor responds and says, I got your command, I got your orders, I'm executing them. All of the commands and all of the responses are composed of ASCII characters, digits, letters, and a few other characters. And that makes it so you can actually watch and read the commands and the responses going back and forth from a sensor. And with SDI-12 equipment, there are usually something called a transparent mode where you can help see this kind of thing. Okay, these are the printable, readable ASCII characters used by SDI-12. You may or may not be familiar with ASCII characters, but it stands for the American Standard Code for Information Interchange. And if you saw the movie The Martian, when the astronaut was stranded on Mars, he initiated communications with Earth using this ASCII chart. So they sent letters back and numbers back, one letter at a time to comprise messages. SDI-12 is, in odd ways, very, very similar to that. It uses the printable SDI-12 ASCII characters, which range from the space, the exclamation point, all the way up to number 126, which is the tilde. So you can see these things going back and forth between the sensors and the data recorders, and they mean something. They're human readable and they make sense. As I said, SDI-12 is a protocol. It has an electrical specification, and it also has a protocol specifying how the commands and responses are received, what the data recorder is responsible to do. It has a byte frame format. This is not something as a user of SDI-12 you need to know, but it has a start bit, 7 data bits, a parity bit, a stop bit. That's 10 bits total to transmit. The letter A would be comprised of 10 bits, for example, and it takes 8.33 milliseconds to transmit a character. SDI-12, when you're working with it, you're working in a world of milliseconds, okay? And here are the steps. And I'll have some diagrams that are going to show this a little better in a minute. Step 1, the data recorder wakes all sensors on the bus with something called a break. That's an assertion of the data line for about 12 milliseconds that says, wake up from your low power stand mode and listen. And then it will transmit a command to a specific address sensor instructing it to take a measurement or do something else. And within 100 milliseconds after getting that address sensor, the other sensors on the bus are going to go back to their low power standby mode. So it's very, very energy efficient, very, very low power. Step 3, the address responser has 15 milliseconds to respond, and it says, yes, I understand you want me to take a measurement. I'm going to have the data ready now. It's ready in 0 seconds, or it might take anywhere from 1 to 999 seconds to take one or more measurements. 999 seconds is roughly 15 minutes. Some water quality sensors do take considerable time to take the measurements. If the sensor is immediately available, the recorder can transmit a command to the sensor and will get the data back. That'll be in a series of numbers. Okay, meaningful numbers from whatever the sensor measured it. If it's going to take 1 or more seconds, then the data recorder stands by and simply waits for a request from the recorder, an asynchronous request which comes back, which indicates the data are ready. The recorder then transmits a command to get the data. The sensor responds, returning the data. Okay, don't let this overwhelm you. This slide's going to be up for just a few seconds. This is most of the command set in the SDI-12 specification. We're not going to go over all of those individually. Once you get the basics down of one SDI-12 command, you essentially understand, you will be able to understand all the rest, okay? So, the basics. In this presentation, I intend to go over the most fundamental SDI-12 commands only, okay? And one's called the acknowledge active command, the send identification command to change address, measurement, and get data. Look at the right-hand column, notice the small letter A. That is the address of the sensor, And most of my examples, it'll be a 0, maybe an 8 or a 5, but that's consistent. And a command always ends with the exclamation point. It always begins with the sensor address. The acknowledge active command is the most basic of the SDI-12 commands. This one just says to the sensor, are you alive? Are you well? Can you respond? It's kind of like a heartbeat command. It asks the sensor if the sensor is alive and well. And here's an example. It transmits a 0. That's the sensor address, the exclamation point, using the SDI-12 timing protocol on the data line, and the sensor will respond back in the appropriate time, 15 milliseconds or less, and say, yes, I am address 0, and it's terminated the CR, and the line feed you're going to see in the specification stands for carriage return line feed. That goes back to the days of the typewriter when you would finish typing a line and you would move the carriage back to the left and it would go down a line, making for a line feed for the next line. So it's a bit archaic. It has its origins in typewriters, but a response is always terminated with a carriage return line feed. The command that goes to it is always terminated with an exclamation point. This is what it looks like when you're looking at the data line itself, the transmission of the characters bit by bit on the bidirectional data line. The first thing that happens here is it sends a break, okay? A break is usually 12, could be longer, 12 milliseconds long, and what that does is that tells all of the sensors to come out of their standby mode and start listening. Then it transmits the 0 and the exclamation point. So this distance here is the bit by bit transmission, 1 bit at a time, 10 bits total for each character. So between here and here, 20 bits are going to go by saying, who are you? Are you alive and well? Okay. And then this is called quiet time on the bus. This would be marking a little bit of delay time. And then the sensor responds, says, yes, I am here with my address, carriage return, line feed. So that's the break, the acknowledge active command, and the response. This shows a little bit of the timing and what it takes. We call the assertion of the data line in a break, or the assertion of the various bits in the ones and zeros is called spacing. And marking is when the data line is in its slow state. And I think of this as, I call it quiet time on the bus. There's nothing happening on the bus, and often that's how these asynchronous communications wait. You put the bus in a quiet state before responding. The sensors will take care of that. When you're setting up your network of SDI-12 sensors, you're going to want to know about those sensors. So there's something called the send identification command, which is the sensor address followed by a capital letter I exclamation point. And that says, I want to learn a little bit about the sensor. I won't go into the details here, but the sensor responds with its address, the version of SDI-12, 14, you put the decimal point as implied. That stands for version 1.4. The company, you might put the company name, and this, I have a company named NR Systems, so I have an SDI-12 product that generated this. The version of my sensor is version 3.0, and a little bit more detail about this is a sensor simulation, and then it's a carriage return line feed. So there I've got the fundamentals. You might get a serial number from the sensor, but you'll know the version number of SDI-12, so the data recorder can adjust accordingly, a little bit about the company name, the version of the sensor. And as every SDI-12 sensor has its own address, typically when they were shipped, the address will be the default address of 0, and you'll want to change those addresses. If you have 5 sensors, you might want it to be sensor 0, sensor 1, 2, 3, and 4. Always start with 0. You can start with 1. You could start with a small capital letter A, whatever you want, but the standard is to use the numbers first. So the change address command, you send the 0 and A for change address, that's the command, and the address you want it to go to, exclamation point. The sensor's job is to change its address, and it will change the address and then send back its new address, in this case 1, again terminated with a carriage return line feed pair. Okay. The next thing to do is to take a measurement. Let's just imagine you have a sensor that takes 1 measurement and it has the measurement done instantaneously. That's called M for measurement. That's one of the key commands is the M command. You send it to 0, the address, M exclamation point, it sends back its address 0. This is called the number of seconds until the data recorder, the sensor measurement will be ready. In this case, 0 seconds and 1 data value will be ready. Simple enough. And then the next step is to get that data. And that you use the D command. Think of D for data, and this is called the send data command. They all come back as a number with it in ASCII characters. For example, here you're sending, you start with D0 exclamation point, and we only are expecting one measurement, so it's plus 0.0 is the measurement. Carriage return line feed. All numbers coming back will either be preceded by a plus sign or a minus sign. This could actually be minus 0.0, and that would be legit. The plus sign and the minus signs are delimiters so that the sensors can fit, so the data recorder can parse out the different data values coming back. Okay. Now, one requirement of SDI-12, and from a user's viewpoint, this is very important. It has something called a transparent mode. That's where you can typically use a keyboard or plug a keyboard into your data logger. There might be a soft keyboard on a screen on a data recorder. Anything might go, but there's a mode in which you can use the data recorder to manually type in commands and get results back as you're setting up your network. For example, to change the addresses, to see what sensors are out there, to use the acknowledge active command to make sure the connections are right. So the transparent mode, I'm not going to read this slide. It's going to do all the heavy lifting for you. And here's an example of the transparent mode. Okay, this is from a product of my design. This is a transparent mode, and I'm going to use my magnifying glass and enlarge this just a little bit right here. Okay, what you do is you type in a command up here where the little hand is, if you can see that, and it gives you the command and response. So I typed the acknowledge active command here, got the 0 carriage return back. I typed in manually the 0i command, and it gave me the make and model of the sensor and the version of SDI-12. I typed in the address command, changed it from address 0 to 1. It changed it, got it back, and then I verified it with the acknowledge active command that it is now address 1. I repeated the send identification command, getting the same results. And then I typed in 1A0, 0 carriage return line feed to change it back to 0. And here I took a measurement with the M command, 0 seconds, 1 data value will be ready, and I got my 1-0 back. That's the transparent mode. It's going to look different from data logger to data logger, but that's the gist of it. All data recorders are required to have it. This is a bit of a recap here. Again, this is the M command, 0M exclamation point. I'm told that in 0 seconds at address 0, 1 data value will be ready. Then I fetch the data with the D0 command, and we're done. So that's a simple case for one measurement, okay? But it's an SDI-12 sensor with a basic command set can return up to 9 measurements. With some other commands, it can return up to 99 measurements, and with even more advanced commands, it can return up to 999 measurements. But for the moment, let's keep it at 9 measurements. So here, I changed, this is a different sensor. I sent the M command, and it says 9 measurements are going to be ready. So I issued the D0 command and got 1 measurement here. I'm expecting 9 measurements, so it's incomplete. So I need to issue another command, the D1 command. I get the 2nd measurement. D2, get the 3rd measurement. D3, get the 3rd. D4, get the 4th, 5th, on until I get to D8. I've started at 0, so 0 through 8 makes for 9 measurements. So I have 9 data values, but I had to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 command response transactions. This is completely valid, completely legitimate, completely in compliance with the specification, and it works. But a more efficient way is the data recorder can send all the data values back at once. It's subject to 45 characters in response to an M command, and more characters in response. You can go up to 75 characters with other commands, but here it's the same data, the same result, but here the data recorder has the intelligence to put them all on one line of code, far more efficient, the sensors can all return to their standby mode quicker. Okay, now in the early days of SDI-12, this is something that escaped and nobody noticed it, and it made it into the SDI-12 more or less well permanently. The first there are different M commands for different reasons, but the first M command, there's no digit after it, there's no 0. But the first D command has a 0 after it. M commands, we're going to get that in a minute. There's the M command, which I've shown you, but there's an M1, M2, all the way up to M9. Notice there's no 0 after the M. Now here's the get data commands. If they start at 0, go 1, 2, all the way up to 9. There is no M0 command. There is no AM0 command, and there's no AD command. That's a minor inconsistency. Just keep that in mind when you're working with SDI-12, okay? Now there's a service request. I said if the sensor is going to take, for example, let's say it's going to take 5 seconds to take a measurement, then the data recorder has to simply wait for the measurement, but the sensor is going to send when the measurement's ready, it's going to asynchronously, meaning at some time between 0 and 5 seconds, it's going to send back the address carriage return line feed saying the data are ready. Here's how that works here on the bus, SDI-12 bus. It sends a 0M1 in this case, and it says in 2 seconds, one data value is going to be ready, carriage return line feed. The command and its response are squished into this little thing, and then 1.5 seconds has elapsed. Here's the carriage return, the service request that says the data are ready. Okay, that's what it looks like. Okay, now here's how it would look if a data logger was actually doing this and running this on a periodic time. In this example, a data recorder is programmed to take a measurement with the M command every 5 minutes. So when it's time to take the measurement, it issues the M command, it gets the 59 in 5 seconds, 9 data values are ready. Sometime later, it can be anything less than 5 seconds or right up to 5 seconds. Here's the carriage return line feed, service request, and then it iterates through the commands as necessary to get all of the data values. And then 5 minutes goes by and it repeats it. I changed the behavior of the recorder here to show again the more efficient way of all of the data values coming back at the same time on the last line. So this would be a real operation of a data recorder, and you can see by watching it, a lot of devices will have what's called a monitor mode where you can peek in and see these characters. That's where I say they're human readable. The QDAT is not part of the standard, and the break, that's just showing a break went out, but all of this is SDI-12, okay? If you understand the M command, you really understand most of the commands. They all work the same, but there are additional commands, and the sensor may or may not support these. They have to support the M command at the very minimum. But let's suppose you've got a sensor that takes temperature and say pH, for example. They could program it so the M command returns the temperature, the M1 command returns the pH, or they could return the temperature and pH in response to 1. So the additional M commands simply provide a means to request different types of measurements from a sensor or to instruct a sensor to do a calibration or a control function. And in my example, in another example, a sensor could measure pressure and temperature. AM1 requests a pressure measurement. AM1 requests a temperature measurements. Additional M commands have the same format as the original M command, and data collection in all circumstances always starts with the 0 or the address D0 command. Okay. As SDI-12 went along and years passed by, it was recognized that some European countries have standards that they want error detection codes appended to SDI-12 data to make sure that the data values that come back were transmitted correctly and the bits weren't mangled or messed up, so the numbers were incorrect. So they added something called a CRC, which is a cyclic redundancy code. The details of that are beyond the scope of this class. It's a mathematical concept where you run all of the bits through an equation, and generates a 16-bit number that the data recorder can decode and determine did the data arrive successfully error-free. That 16-bit number is translated to ASCII characters to comply, and you see it here in these odd characters here. And you get that CRC code by putting a C for CRC after the M command. So these are called the MC commands. In your data set in the loggers, however, these CRC codes will not be stored. As a user of SDI-12, you do not need to be at all concerned with them. The data logger will throw those out for you. And if the CRC indicates the bits were mangled, it's the responsibility of the data recorder to do a retry and try to get the data again next time error-free. Okay, now, it was quickly recognized that if you've got a complex sensor like a water quality sensor, and if it's going to take 99 seconds, that's a long time. That's a long time, 15 minutes, 999. Under SDI-12, the data line has to be quiet. You cannot communicate with other sensors during that time, and that's essentially dead idle time, because if you put a brake on the bus to wake the sensors, that causes the measurement to terminate. So we came up with concurrent measurements that work identical to the M commands, but you can kick off sensors and have you can have two or more sensors taking data at the same time. So you can kick off sensor 0. If it takes 5 seconds to take its measurement, then you can kick off sensor 1. It may take 15 seconds to get its data, and you can kick off sensor 3, and then you can collect the data as it becomes available as the times expire. So the concurrent commands start with AC instead of M and go up to AC9, and you can also request the error detection code by putting a CC, so that stands for concurrent with the CRC here, okay? And here's the difference. This simplifies things, the concurrent commands. There's the same scenario where you're using a concurrent command as opposed to an M command. In the M command, you send the 0M exclamation point in 5 seconds, one data value will be ready. Then you wait for 5 seconds or until you get a 0 carriage return line feed, step 3. Then you use the D0, then you get your data. For concurrent, it's a little bit more efficient. Notice that step 3 is gone. Step 3 now changes to getting the data, so it's 4 steps instead of 3, and the data recorder can make use of the time the sensors are taking the measurements to communicate with other measurements. Here's an example of concurrent measurements. I'm going to try to enlarge that a bit here for you. Okay, we go out here and say, in this case, now with concurrent measurements, there's 2 extra digits. You can get up to 99 values back instead of 1, so there's a little more digits. You'll see that in the SDI-12 spec. So in this case, in 10 seconds, 1 data measurement is going to be ready. So then it queues another sensor at the next address, in this case address 5, and it's going to have a data value ready in 5 seconds. There's no service request. The data recorder has the intelligence to get the first data reading from the sensor that took 5 seconds, and then it goes back to the first sensor. Okay, so there's a period of time where both measurements are working, both sensors are taking measurements simultaneously. Oops. Okay, let's get back to that break. The break is raising the data line, asserting the data line for 12 milliseconds. And by asserting the data line for 12 milliseconds, that's not going to be a bit pattern that's going to be recognized as a letter or a command. It's a perturbation. And that is the purpose of the break, is to wake all sensors on the SDI-12 bus. But you can use that break if you're taking if a data recorder is taking a water quality measurement that takes a great deal of time and doesn't want to wait, it can issue a break to stop that measurement. So you can stop a measurement in progress. That's why you have to wait on the bus before you get your data with the M commands. But for a concurrent command, it will ignore a break and keep working. So if this data recorder wants to stop a concurrent measurement, it has to send another command to that sensor For example, while taking a concurrent measurement, if it says it takes 10 seconds, during that 10 seconds, you could send the acknowledge active command to it, and it would respond to the acknowledge active command, but in the meantime, it would kill the measurement it was taking that you wanted to stop. Okay, this is the SDI-12 timing. As a user of SDI-12, you really don't have to concern yourself with this, but it's good to have a kind of a conceptual understanding. So the data recorder sends a break, wakes all the sensors wake up, and the sensor then it waits a little bit under the specification. It has to wait for a certain amount of time, at least 8.33 milliseconds. Then it transmits the command, and then the sensor has to respond and it has to set the data line to its quiet state for 8.33 milliseconds. Then it responds and returns the result. And for most commands, this entire thing takes place in less than half a second. Okay. In some cases, with D commands, after you can get 75 characters back for your data with the certain commands, so that kind of doubles it to 780 milliseconds, still less than a second, and in another case, 810. So relatively, everything's going to be less than a second. However, if you're using what are called high volume commands, which are beyond the scope of this class, you could literally get back 999 64-bit numbers, which is a huge amount of data, and that would take 10 seconds. We're not going to get into that in this class, but that's the fundamentals of the SDI-12 timing. And now we added into SDI-12 as it became more and more popular. Users of SDI-12 wanted to have SDI-12 tell them and have the sensors give information about how they work and what they measure. So we introduced metadata in version 1.4 of SDI-12. I think we introduced that in the year 2017. And that way you can use SDI-12 to ask the sensor and say, well, what do you do? What measurements do you take? Okay, so there are two types. There's the identify measurement commands and the identify measurement parameter commands, meaning if you're going to take if you're going to return 5 different data values, what's in data value 1, 2, 3, 4, and 5. So the identify measurement commands just tell you what you're going to expect, because the timing may be of interest to the data as you're setting up the data recorder. How long do these sensors take to take their measurements? They work just like the M commands, except for you put an I in front of the command. And you get the same result you would get from the M command. In this case, in sensor address 0 in 00 seconds will return 1 data value. Or in this case, in 10 seconds will return 9, and another example here. But the difference is it's telling you what it would do if you really asked it to take data, but it's not going to initiate a measurement. So now you know how many data, you know how long it's going to take for the sensor to do its thing and how many data values you'll get back. Okay, the next one is details about each measurement. So for example, if it's going to measure turbidity, dissolved oxygen, pH, temperature, what order do these come in? So this is a recommendation. The first, you're going to get various fields back. It's going to come back and say, the first one is we recommend you use the chef code, the standard hydrometeorological exchange format, some description of what the sensor is measuring for that parameter, okay? And if a chef code is a recommendation only, the sensor manufacturer can kind of roll their own and other description would be appropriate. These are separated by commas. The next one be the units. And the third would be the optional fields. Now, how that works is you have to add a little bit more information to your request. So again, use the sensor address, I for identify, the M command underscore, and it's always going to be 3 digits. So here you're saying, I know you're going to take at least one measurement for me. I want to know about the first measurement. So you get the address back, you get field 1, a comma. So field 1 would be the chef code. Field 2 you'll get back would be the units. Field 3 would be additional information. these are terminated with a semicolon. And the sensor manufacturer will do that for you. You don't have to really worry about that. And again, the always carriage return and line feed. And here's another example with real data. And again, you want to learn about the first parameter. The chef code is PR. The units are millimeters. More information is the precipitation rate per day terminated by the semicolon. This has been really popular. This was introduced in version 1.4. And it was accepted and is in use, as far as I can understand, by numerous sensor manufacturers. We also introduced high volume binary, which we'll talk about in a minute, but that has not taken off as well. But this has proven to be very, very useful. And as users of SDI-12, I think it'll be of great value to you. Okay, this is just a little bit more detail. So I will go quickly here just to summarize. Field 1 is the chef code. Field 2, the units. Field 3, you can add what you want. The sensor manufacturer can add what they want. You will not be doing this as a user, and has up to 75 characters to explain it. Okay. We added high volume commands to version 1.4. And it works beautifully, absolutely beautifully. You can get tremendous amounts of data from these SDI-12 sensors. You can get up to 999 data values as ASCII characters in what we call the high volume ASCII command, and that'll work just like your M command, except for now you can get 999 data values. So the D commands will range from D0, D1, D2, D3, all the way up to D999, which you'll never need, but you'll need 998 to get all 999 as you're starting with 0. So you already know how to use those, and works fine. But then there's the binary, where you're no longer using ASCII characters. You're getting at as binary numbers, the ones and zeros that the numbers are encoded in. They come in a data package that is not human readable. If you look at it on the SDI-12 bus, it'll look like gibberish to you, but it is value data. It has error detection in it with a CRC, just like the other ones. And you can get 8-bit integers, 8-bit signed integers, 8-bit unsigned integers, 16-bit, 32-bit, 64-bit, and you can even get IEEE floating point numbers in 32 and 64 bits, so you can get extremely large numbers and extremely small numbers, taking it out to 1.10 to the minus 208th in some cases, depending on the thing. But that's way beyond the scope of this class. And here's a summary of the SDI-12 versions. SDI-12 was invented in 1998, and for the first several years, it was version 1.1, and then in 1994, it jumped to 1.1, but 1.1 and 1.0 are technically identical. It's very rare you will see the 1998 1.0 version specification that's served for 98, 99, and up to 1994. If you get a hold of that one, don't read it. Go to the website and get the most recent version. But if you have a 1.1 sensor or 1.1 sensor, know that they are absolutely identical. There's no technical difference at all, none whatsoever. Version 1.2 was introduced in 1996. We added concurrent measurements. In 2000, version 1.3 came out. We added the CRC error detection commands, and that was actually to support requirements in the European Union for data error detection. And in 2016, I said 2017 earlier, the group voted to have the high volume commands and the metadata commands. And in spite of all this, if you were able to go out and resurrect the first SDI-12 sensor that was ever made in 1988 and put it with the most modern 1.4 data logger you could get today, they will work together. So the backward compatibility will absolutely work, guaranteed, if and only if both the sensor and the data recorder are in compliance with SDI-12, okay? And that is kind of the end of my presentation. I am making this presentation from a hotel room in Seattle, and if you've been following the news, it's very hot here. So my last slide is going to be kind of a winter scene, but I forgot I had one more. The SDI-12 support group, we're here to help, okay? If you're using SDI-12, if you're programming SDI-12, if you have any question whatsoever about SDI-12, send an email to that address right there, and you will get an answer, usually within 2 business days. We read each and every email we get, and we respond to 100% of them all the time as soon as we possibly can. SDI-12 is described in excruciating detail with many, many, many examples, and you can get us, the website is www.sdi-12.org. You'll find the specification there as a PDF file, and it explains everything in great detail. I think it's about 60 pages long, but we will help you. Any questions you have. And getting back to the heat here in Seattle, where it's been rather extreme, I'm ending mine with a winter presentation of a scene in Utah to cool everybody down. And with that said, that's the end of my presentation. And if there are any questions, I will do my best to try and answer them.
Okay, well, thank you for that, Michael. We did have one question pop up, and let's see, let me read it here. It's asking if you could talk a bit more about the ability to use the ARN for continuous measurements, ARN command.
Okay, could you repeat the question? You mentioned continuous measurements?
Yeah, could you talk a bit more about the ability to use the ARN for continuous measurements? That's
okay, got it. Okay, that is a command we didn't talk about. I didn't talk about. The R command is the A, and the R commands are, let's say you have a sensor such as a shaft encoder, okay? And it has its measurements, a sensor that has its measurements ready immediately, okay? You can just say, what is your data value right now? So it doesn't require any time to take it. So it would be 0 seconds, it's ready in 0 seconds. You can forego using the M commands, you can forego using the C commands, and you can essentially get the data directly using the R commands. And so you would send the address, the A, the R, the 0. They always start with 0, just like the D commands, exclamation point. And if you have a shaft encoder, all you have to do to get the shaft encoder reading is send the address, the capital letter R, exclamation point, and you will get your data value back. And if you know the sensors you have and how they work internally, you go AR1 after 0, AR0, then AR1, AR2, AR3, just as you increment up through the D0 commands to get all the measurements from the sensor. So it's the continuous measurements are a shortcut way to get data from sensors that has the data immediately available. Does that answer the question?
He says thanks. So it must have answered his question.
Okay. Any other questions?
I'm not seeing any other ones pop up here. I don't have any myself. So without any more questions, I can go ahead and terminate this webinar. Thank you again, Michael, for giving that presentation. And for everyone's benefit, the recording will be put on our YouTube channel again. And as soon as the recording gets put up there, I'll get the certificate for your CFM credits, and I'll send all that out in one email. So with that, I'll terminate the webinar. Thanks again, Michael, and thank everyone for your attendance today.
Okay, thank you all for attending, and thank you for inviting the SDI-12 support group to offer this short tutorial.
You bet. Y'all have a great day.
You too. Thank you.